Okay, for our first problem, we're going to be creating a stem and leaf plot for this data. This data is the previous statistics exam grades for 20 students. So take a minute, enter the data into your calculator, and I will review with you the steps for writing a stem and leaf plot. So I put my 1-var stat test results up on the screen, and our first step is going to be to sort the data in order. So I'm going to do that by going to stat and then number 2 for sort in ascending order. And I used list 1, so I pressed second and then 1 to get to list 1. Then I pressed enter. And now when I go back to my list, you see that the numbers are in ascending order. Step 2 is going to be to identify the stems, which are every digit except the last digit. So here, my stems are going to be 4, 5, 6, 7, 8, and 9. The key to remember is that the stems are every digit except the last digit. So what I'm going to do is I'm going to write out my chart, and I'll have a stem column, I'll have a leaf column. So here I'm going to need the stems 4, 5, 6, 7, 8, and 9. The key is you have to include any missing stems. So let's say I have my data values and I had 46, but let's say I was missing the 2 numbers in the 50s and I went up to 63. I would still have to include the 5 as a stem, even though there were no numbers in the 50s, because you must include any missing stems that go from your smallest number to your largest number. Now what we're going to do is we're going to write the leaves in ascending order for each stem, and duplicate numbers must have duplicate stems. So for example, I have 46, so the stem of 4 must have a leaf of 6. I have 55 and 57, so 5 is going to need a stem of 5 and 7. Now look at the numbers in the 60s. I have 63 and 2 67s. So I'm going to need a 3, and then I'm going to need 2 7s for the leaves of 6. For the numbers in my 70s, I have 72, 74, 75, and 78, and you see how I'm aligning my leaves so the graph is easier on the eyes. I have for the 80s, 81, 83, 84, 87, 88, and 89. And then for the 9s, I have 91, 92, 97, and 98. Using either the smallest or the largest number, so either using 46 or 98, you must include the key. So you're going to write the word key. I'll use 46, so the stem is 4 and the leaf is 6, and that represents the number 46. The key is going to be vital because it tells the reader what these numbers represent. Now we're going to be using the same data to do some percentile rank questions. And the formula that we use for percentile rank is the number of data before the given value, the number of data less than the given value, plus 1/2 times, that's multiplication, times the number of data at the given value, the number of data equal to the given value, divided by the total number of data. Well, look at letter D. Find the percentile rank of 67. So what we're going to do is we're going to find 67 on our list, and notice there's two of them. We're going to take the number of data before the given value, the number of data less than the given value. So that would be 46, 55, 57, and 63. They're all less than 67. So there's 4 data less than 67. So we're going to go 4 plus 1/2 times the number of data equal to the given value. Well, the given value is 67, and there's 2 67s. So I'm going to do 4 plus 1/2 times 2 divided by the total number of data, which in our problem was 20. So what we're going to do is we're going to enter this into our calculator. And notice when we do this, we get 1/4, which converted to a decimal is 0.25. So that means we say that 67 is in the 25th percentile. What does that mean? That means about 25% of the data is less than 67. Now, a couple things. First, make sure you write 25th, 25th, and not 25%, because in statistics, those things mean different values. And then second, you always have to remember that you round up if you get past a certain percentile rank. So for example, 0.25 is the 25th percentile. But if you would have gotten 0.251, that means you're past the 25% mark, and now you're in the 26th percentile. So you always have to remember that when you do percentile rank problems, you always round up accordingly, because basically percentile rank are like stages. You have the 25 stage, the 26 stage. If you get 0.25, you're right on the 25th stage. But if you get 0.251, you're just past the 25th stage, which means now you're considered in the 26th percentile. So always remember, for percentile rank, you always round up. Look at letter B. Find the nearest score that falls in the 86th percentile. So now I don't need to know a percentile rank like 25th. I need to know which of these numbers, which of these scores corresponds to the 86th percentile. So this is what you do if you are given a percentile. Well, the first step is to always make sure your data is in ascending order, and we have that from our previous problem. What we're going to do is we're going to calculate the percentile ranking over 100. Here, they want to know which score falls at the 86th percentile. So we're going to do 86 over 100 times the number of data values, which we were told is 20. So we're going to do 86, because that's the given percentile rank, over 100 times 20, because we have 20 data values. Here, when we do that and we convert that to a decimal, we get 17.2. We're going to round up. Normally, 17.2 would round, if we're rounding to the nearest whole number, to 17. But here we're going to round up to 18. The value calculated in step 3 is the place in which the answer lies. So that means the 18th number in our list corresponds to the 86th percentile. Well, remember, I had 20 numbers. The first number was 46. The 20th number was 98. Here, the 18th number is 92. So we say that 92 corresponds to the 86th percentile. So that's what you do when you're given a percentile rank. Finally, for part C, find the nearest score that falls at the third decile. Well, Deciles break the data up into 10 equal parts. Percentiles break them up into 100 parts. Well, deciles break the data up into 10 equal parts. The first decile is the same as the 10th percentile. The second decile is the same as the 20th percentile, all the way through the 9th decile correspond to the 90th percentile. So this one here says find the nearest score that falls at the third decile. Well, basically the third decile is the same as the 30th percentile. So what we're going to do is we're going to use these directions to find the value for a percentile ranking. But here, the percentile ranking that we're going to be using is 30. So we're going to take the percentile ranking, which is 30 over 100, multiply it by the number of numbers, which is 20. And here, when you do that on your calculator, you get 6. It says round up to the nearest integer, but 6 is the nearest integer. So that means the 6th number in our list corresponds to the 30th percentile, which is the same as the third decile. So we'll find our 6th number, 1, 2, 3, 4, 5, 6. So here our 6th number is 67. So 67 corresponds to the third decile. So this next problem, they're giving you a stem and leaf plot, which is used to display the number of vehicles sold by the Ford and Nissan dealerships in a town each week for a 3-month period. And here, this is what we call a side-to-side or a back-to-back stem and leaf plot. For this type of graph, what they do is they put the stem in the center and then the leaves on each side corresponding to each data set. So basically, we have to read it from inside out. A stem of 3 with a leaf of 0 to the left corresponds to the number 30. And 30 would be a value for the Ford dealership since that's on the left. A stem of 3 with a leaf of 5 on the right would correspond to the data value 35 for the Nissan dealership because the Nissan data is on the right. So basically we have to read this from inside out based on which data set we're dealing with. So what we have to do is we have to enter our data and calculate the mean for both distributions, the range, and the interquartile range. So we're going to have to set up 2 different lists. First, I'm going to set up my list in list 1 for the Ford dealership. So notice my data for the Ford dealership. I have a stem of 0 and a leaf of 4, so that corresponds to the number 4. A stem of 0 with a leaf of 7, that corresponds to 7. So make sure you have the same data as I have, and I'm going to run my 1var stat test for the Ford data. So for the Ford information, my median was 15. The range of the data, remember that's the maximum minus the minimum. So that's going to be 30 minus 4, or 26. And then the interquartile range, that's Q3 minus Q1, 24.5 minus 10.5. So that gives me the interquartile range, the IQ or the IQR, of 14. Now take a minute, enter the Nissan data into your calculator, and run the 1var stat test for that set of data. Okay, so here's our data for Nissan. Our median turns out to be 11. The range, the max minus the min, so that's going to be 35 minus 3, or 32. And the interquartile range, 24.5 minus 8.5, so that gives us 16. So that's what we call a side-to-side or a back-to-back stem and leaf plot. For our last set of problems, we're going to look at the association between percentile ranks and data itself. So, percentile rank is important because it breaks the data up into 100 little portions. And a box and whisker plot kind of ties in to percentile rank. Remember, on a box and whisker plot, you're given the minimum value, you're given the lower quartile, you're given the median, the upper quartile, and the maximum. And the significance of a box and whisker plot is that it breaks the data up into quarters. 25% of the data falls between the minimum and the lower quartile. 25% of the data falls between the lower quartile and the median. 25% between the median and the upper quartile, and 25% between the upper quartile and the maximum. And these sections don't have to look to be the same amount of data values. Like, for example, this 25% section looks a lot smaller than this 25% section. And that's because the numbers might be spread out or together in certain spots. For example, you might have the data values 32, 32, and 33. And you might have the data values 34, 41, and 42. Each of these sections has 3 data values. But you see how these 3 data values are closer together. These data values are further spread apart. They both have the same number of data, but they each possess 25% of the data. So let's answer some questions that deal with box and whisker plots and percentile. It says the median of the data represents which of the following percentiles? Well, remember the significance of the median. 50% of the data is less than the median, and 50% is more. So that means for percentiles, the median corresponds to the 50th percentile. The 75th percentile is known as the, well, think about how the box and whisker plot breaks up the data. 25% is between the minimum and the lower quartile. 25% from the lower quartile to the median. 25% from the median to the upper quartile. So the upper quartile is the spot that 75% of the data is less than. So we say that the upper quartile corresponds to the 75th percentile. So the lower quartile is the 25th percentile, the median the 50th percentile, and the upper quartile is the 75th percentile. Number 3, a box and whisker diagram shows for data below what is the 25th percentile value for this data set. Well, the 25th percentile is the lower quartile. So we're basically going to be looking for where Q1 is on this box and whisker plot. And remember, the lower quartile is the left portion of the box and whisker plot. So the lower quartile is right there. So we have a number line from 0 to 50 with 4 sections in between. So it looks like we're going to have 10, 20, 30, and 40. So we're going to say that the lower quartile corresponds to 20. Finally, if a data set has 500 values, how many of these data values lie above the 85th percentile? Well, here's how percentile rank works. Percentile rank gives the approximate percentage of the data that's less than the given value. The key is percentile rank is the percentage approximate that's less. So the 85th percentile has about 85% of the data less than that value. Well, since the entire section is 100%, that means that only 15% of the data lies above the 85th percentile. So that's what this question is saying. How many of these data values lie above the 85th percentile? Well, that's going to be 15%. But this doesn't say what percent of the data is above. This says how many. Since they tell you that there's 500 values, you know that 15% of the 500 have to be bigger than the 85th percentile. So to get your answer, do 15%, 0.15, times 500 on your calculator. So that's going to tell you that 75 data values are above the 85th percentile. That means the rest of them, or 500 minus 75, or 425, lie below. So that's the significance of percentile ranks. Remember, percentile rank is the percentage of the data that's about less than the percentile. So the median is the 50th percentile, so about 50% is less.